This is a question that came from an algebra student, and there's a lot of overlap between this and statistics, so I'm going to file it under statistics also. Given the number of cigarettes smoked per day, a mathematical model for the life expectancy is f of x is equal to negative 0.6282 x plus 85.72. This is a mathematical model, it's an equation, it's a function. Here's some algebra, do the algebra. Evaluate the life expectancy of someone who smokes 40 cigarettes per day. Round to the nearest tenth. The answer is shown at the bottom. Notice how this mathematical model has the y equals mx plus b kind of a setup. Have you ever wondered where the mathematical models come from? Where did they get these numbers? Well, the answer lies in statistics, and we're going to use some technology today to kind of figure out how to do that. I'm going to start with Excel first because I can fit all of the data on the same screen. So pause right here and get this data into devices. After you get that data in, then we're going to highlight all of the data, all the numbers right here. Now this represents the number of cigarettes that were smoked per day and then the age of that someone was at death. So we have all these measured spots. Now truly, if we were going to do a genuine statistical study, then I would need a whole lot more data points in this, but I want it to fit on one screen. We're talking about how to do the math today. So I'm going to go to Insert right here, and then I'm going to click on Charts right here and pick a scatter plot. Now notice how there's no line here, but you can kind of see the shape of where a line would go. It would be somewhere right here. So these are going to be all my x's, these are going to be all my y's, and then when I plot all of those, there's not a line, but there's a line-ish kind of a situation going on over here. By golly, I wish I had the y equals mx plus b that fit this data as best as we can. Here's what we're going to do. I want you to right-click on any of the points. We're going to add a trend line. We have a lot of options. Today we're doing linear regression, so I'm picking this one. I'm going to let that one stay there. Scroll down to here. We're going to display the equation on the chart, and look at that y equals mx plus b. That's where that's coming from, in this space over here. All right, so that is that y equals mx plus b situation. That's coming from those data points. It is the closest one to fit all of them. And from there, then we can start plugging in values. Remember the value that we got when we plugged in 40? Let me see how it fits on that line right there. We're going to use this line to make predictions. So that is the equation of the line of best fit that takes all of those data points into account. If you are working with the TI-84, you're going to go to Stat, and it's already on Edit, so you hit Enter. And I want you to get all of your X's in here and your Y's in here. That is the cigarettes per day into L1, and then the age at death into L2. It's on the side because I can't fit all of them on this screen. So use the table to the left of this calculator. Once you have all of your data in here, then I'm going to go up, up. You see this is the end of it. Just make sure that your list matches my list. Make sure that they're the same length, that the correct x's matched with the correct y's, all of that stuff. Now that you have that in there, we're going to go back to Stat. We're going to go to the right to Calc, and we're going to choose number 4, linear regression, and it's that ax plus b format. So I'm going to choose 4. Your X list should be coming from L1. That's where you put your X's. That's where you put your cigarettes per day. And your Y list should be coming from L2. That's where you put your age at death. Enter. It gives you this pattern right here that the A, or the slope, is going to be this number right here, and your y-intercept is going to be this number right here. These other numbers we're going to talk about in statistics a little bit more. We're going to talk about the correlation, the strength, coefficient of determination. In algebra class we don't care, in statistics you might care. All right, let's do that again, but with a few more bells and whistles. So if you want to look at your data, We're going to hit second and y equals, and I'm going to go into my stat plots. I want to turn one on and tell it that I want a scatter plot. Your X list is coming from L1, your Y list is coming from L2, and then I'm going to zoom, and you see how number 9 is zoom stat? Whatever you have turned on in stat plot, you'll be able to see in zoom stat. So zoom, and then the number 9, and it will tell your calculator to zoom in on whatever it thinks is the important information. If you want the line to show up, we have a couple of options. You could go to y equals right here and type in -0.6282, your x is up here, plus 85.72, and then when you graph, it'll show up right there. Another thing that you could do, I'm going to clear that out. You don't have to clear it out. You go to Stat, Calc 4, you're going to be real fancy pants with it. We're going to tell it to store the regression equation in y1, so you don't even have to type it. So go to vars, go 1 to the right for y vars, function, where do you want me to put it? We're just going to pick y1 since we just cleared that out. And then enter, enter. And it gives this on screen, but it also puts this right here. So you just have that equation populated for you. And when you graph it, it is right there. You can find anything that you want to from here. So trace, and it's locked onto the plot. I'm going to go down to lock it onto the equation. And if I type in 40, it will show me this value right here. Now, any of these data points right here, these are actual values. These are individual people who were assessed and included in this sample. The sample that we are using to find this. So these are all, these little dots, and these all represent humans. And then this represents a line that's the prediction, so that I can use the information to predict what would happen if someone said, I smoke X number of cigarettes per day, then this is what it's going to do to your life expectancy. Clearly, these are too few data points to make a real study, but this is about the level that you might get right now, just so it's not overwhelming. So this is how you figure out what the best y equals mx+b is based on a data set. And one last thing, especially if you are an algebra student and you're going to need your calculator to be doing other regular algebra things, just to go back and clean it up. Second, y equals, we're going to go turn the stat plot off. You could do it here, like that. The other thing that you could do, let me turn it back on for a second. The other thing is you can do it in y equals. Sometimes you're going to have dimension mismatch, or something's going to go wrong, and you go to y equals and you see, oh, your plot's on, and you can turn it off from right here. You can clear out this equation. Like clear, clear, done with that. And then also if your graph is over here because zoom 9 put us over here and we want to just return to normal, zoom 6 will return it to normal. So that's just your cleanup so that you can go back to graphing regular y equals mx+b. So 2 over 3, whoops, delete over 3 x plus 4, and then you graph it. Now it's normal again.